Yeah. So you can see the screen.
Yeah.
Thank you.
Thank you. So about the outcome and lesson learned. In this case, like we'll start with the work package WP3, where we define our specification and state of the art. So that the goal was to actually find the current state of the art use of artificial intelligence, especially in the ATM domain, and define our roadmap, what need to be done within this project. So for that purpose, we done extensive literature review, use of AI for supporting ATM, and from that we tried to formulate what problem we can address in this project. So for example, we found that delay propagation and conflict avoidance, this we could address. And then for that purpose, since there are many machine learning algorithms that had been used in this domain, so we just focus on two algorithms, neural networks and random forest. And for the explanation, actually, so what type of explanation method algorithms can be used with these two algorithms? We try to investigate that and find and selected three algorithms: SHARP, Lyman, and FISH. So they have different purposes of giving explanation in different levels. So the idea is to actually then compare the outcome or of these algorithms giving explanation for these two algorithms. And also, like for giving the transparency and explanation in a more intuitive way, we are focusing on visual analytics. So data visualization with static data visualization and interactive visualization techniques, or maybe virtual reality, that kind of approach. And as I mentioned in my previous presentation, that we are also focusing on lifelong machine learning, so that algorithms can learn longer in long run. So for that purpose, we have selected two methods, especially for the machine neural networks. One is learning without forgetting and progressive neural networks. So, and we think these algorithms are well fit with the problem that we are trying to address in this project. And for the tasks that we want to solve in this project, we run a workshop regarding that to find out possible tasks of ATM domain. And you can see, like, there are the tasks are categorized into 4 groups. And they are not only people from AI, but also from the ATM domain. So experienced operator at course and experienced people working in the ATM domain have been involved in this workshop, and their input has been taken into account for defining the taxes. And the this is the one outcome. So you can see, like, optimized capacity is the most address tax that ATCOs want to use AI and explanation. They need explanation in this, and that's where they are prioritized their taxes. So, for example, we are targeting a delay prediction, but it's less prioritized than the tax B. But the lesson in the need of explanation and data availability in this case. So still, it's the optimized capacity is the most prioritized tax, but we could not find actually a relevant data set that we can use for developing machine learning models for that. So that's why we have to trade off between what we can data we have and what problem we want to solve. So that's is the one issue within the project. So maybe we have to mitigate with that problem. So that's why we are considering more issue instruction, that is maybe conflict resolution and delay prediction, that that data that we already have and we can get from Eurocontrol or synthetic data set that we can manage. And from the workshop and the literature review, this is a roadmap that we have defined for machine learning or AI algorithms. So as I mentioned, for the tasks conflict resolution, delay propagation, or takeoff prediction, we are focusing on 2 machine learning algorithms, neural network and random forest. And the transparency, giving transparency or explainability to these models. Three algorithms, NFIS, Lime, and SHARP will be considered, and we will develop model around these ideas. And for lifelong machine learning, we are considering continuum neural networks or progressive neural networks. And another thing that we found that for random forest, not much have been done considering lifelong machine learning. So we are considering developing evolutionary approach to build a random forest that will learn from one generation to the next generation when we train the model with new data set. And for causality, we are considering structural causal models. So in AI, lots have been done using structural causal models. So the idea is actually to consider those methodology and bring those into the ATM domain and try to build causal structural model that will be beneficial for giving explanation. And that can be used both for visual explanation or other kind of explanation. So about that work package 4, still we are conducting this tasks. So there we are considering neurophysiological measurements to measure the mental effort and emotional states based on the explanation. So what will happen if we provide explanation to the operators, and without explanation, how they perceive the models. And there we are also considering HMI technique. So that will help us to actually open up the black box models. So based on the input from this experiment, so we will going to run simulation experiments when we have finally built these XAI models with the human operators, and these neurophysiological measures will be collected to analyze their interaction with the XAI models. And as I mentioned, like also for the lifelong machine learning, not just only to develop the models, how they actually these models we can integrate with passive brain computer interface. That is another idea, and that will give us like how we can develop UX system for that course that will more interesting and more explanatory for the operators, and also for the model perspectives, how this can be like improved based on the input from the user. For that test and validation, this is still on discussion, and we are planning for validation plan. So the idea is to actually the partners will design test cases, and based on the tasks that we have defined in the specific design and specification, and different scenarios will be used for this experiment. And based on that, we will develop data collection and the guidelines in future with the project of this. So talking about guidelines and trainings, the idea is to develop this model and create guidelines for future deployment of AI methods in this ATM domain. So not only just to end here with the developed model, but what kind of constraint that we need to face, or what are the issues that should be considered when developing XAI models for within ATM domain, and also like what data set maybe we will need, what kind of information we can integrate, all this, and also like that what kind of scenarios we can investigate. So all these are into consideration right now, and this will help us to refine the guidelines for training purposes of new ed course. I think this is all for now from Artimation project.